Okay, so in the last video we were done till the introduction of the Coulombs law. Okay, so this will be the second part. Some important points we'll be discussing here. Coulombs law. So if you have not watched that video, I just want to give you a small overview that if you have this charge, this is Q1 and there's a distance which, and here we have Q2 charge. Okay, this is R denoted by R, this is Q1 and this is Q2. So there is a square of these charges, like the distance is electrostatic force between these two charges is directly proportional to the magnitude of these two charges. Oh wow, this is looking like a sunglasses. Well, and there will be a square on the distance between them, the distance which they have, this will be a square. Okay, so now I just want to write or prove you or tell you much more about Coulomb's law, that the force act along line joining center, like joining from the center of two charges. Okay, this is the force which is acting along these, which that force is electrostatic force. Okay, then this is very important point. Now we are going to like drive or to tell from where we get the formula, which is let me just take color. So the formula is F is equal to K Q1 Q2 Q2 upon R square. So now we need to know how does we just get this. So first thing is that the definition exactly says there is a force and the force is directly proportional to these two charges. This one, like first is Q1 and second is this Q2, these two put charges. Okay, so now F and F is not is equal to but directly proportional, as I told you, directly proportional. When we remove directly proportional, then we are at K. Okay, I will tell you that later on. Then F is directly proportional to the charges Q1 and Q1 Q2. Okay, so this is only the one part still, and the definition still says that it is, so the directly, like the inversely proportional to the square of distance between them. The R is the distance between them. So the definition and the part of the definition says that the force which is inversely proportional, when we just write inversely we add 1, which inversely proportional to the distance between them, square of the distance. Okay, so R square. Okay, so now we need to know how we just get this one formula. So when we just write F, because we're supposed to write F just because we are finding that, and when we just remove K, now K, what exactly is this K? Let me tell you, there's a concept of K is a constant value. Constant. K is a constant and depend upon a medium. Depend upon medium, and this is not constant everywhere. Okay, not constant. This is not constant as a universal constant. Not known. Let me just write not known as universal constant. What does this mean? Like K is a constant which depend upon the medium. That's why this is not known as universal constant, just because we have another G which is everywhere constant. So the value of K is equal to 9 multiply 10 is power 9. I'm just writing, you can understand it. Okay, so yes, that is free in space and dissolve, but we'll discuss that later on. So now we just get, when we remove the is equal to, we just write K, and here we get the first charge Q1 Q2, and here we have the distance, square of the distance, R square. So this means simply we get the formula of this question, which is F is equal to K K constant Q1 Q2 upon R square. And if I just talk about the constant K, that is Newton meter square upon